got this. Yeah, so is there anything obvious we need to do? Autogen, sprite offsets. Yeah, so sprite offsets. Well, before we do sprite offsets, I want to do a grid, just a world unit grid, which is also, I mean, the world isn't going to be that big, so we can just draw the whole grid, get all of those rects in there. Although, in order to be able to do that, we need to be able to draw rects that are just solid and not textured. And, well, since we are kind of, you know, pulling our colors out of a texture, essentially. Now, that's another thing, actually. Is, index position, offset, texture. Oh yeah, another thing is that we're not actually using this color, so I'm just gonna remove it. Wait, hold on. Well, to draw rectangles that are colored, we kind of do need the color. Okay, so that's the first step. There we go. The first step is to pass the color in here, so it's a float 4 color. Okay, so we pass in color. Output color is just input color. Not gonna be modifying it. It's the same color for the entire rectangle. Not gonna be like changing it. Yep. Okay. So then go here, rect instance. Okay, where's color? Just before mirror. I mean, I guess color. Like we are gonna have a fair amount of these. I mean, let's call it color 01. Well, it's also. Should I just make it a V4? Type def struct v4 union struct f32xyzw and RGBA. Yeah, I think that works. Anyway, so that's a V4. Oh my god. Comes just before mirror. Okay, so that's gonna be set to zeros. So if it works, it doesn't, but like, oh yeah, we didn't specify that it's a part of the input. Color RGBA. Alright, so you know what, this alignment, maybe just don't do it. Maybe just don't do it. Yeah, so this is gonna be color. Yeah. So they should disappear because we have alpha 0. So when we are pushing these rects, now let's just apply a color. For the first one at least, color is A is 1 or something. So this goes into here. It's inside this struct. Yeah, so now everything's black because the colors are all 0. So R G B B yeah, so that's what we had before essentially. Alright, well, make the other rect do that too. There it is. Okay, so now that we have colors, we should be able to draw solid rectangles. We just need to provide a texture. I mean, we could provide a place in the texture that's just white, like a white pixel, and just draw that. I mean, it's kind of hacky, but having to switch out pixel shaders is also kind of not really what you want, so maybe I'll just do that. And since we're reading everything from these asprite files, I might as well just create one with just the white pixel in it. Perhaps. Instead of like trying to special case it, it's like, oh, most rectangles come from asprites, but like this one doesn't. Width, can you do 1 pixel by 1 pixel? RGBA, transparent, background, there we go, background white. Well, actually, what happens when you do background white? Square pixels, oh, let's find out. So there's our 1 white pixel. I'm gonna save it. White pixel dot asprite. Okay, so this should actually crash here. Yeah, that's correct. Okay, now we get to play the game of let's synchronize some enums. Commando Lemurian. Actually, the first one could just be this white pixel, right? And this could be Commando. Okay, and here we can just go like else if white pixel. Also string starts, maybe I should just check for the whole, well, maybe I should just check for the whole file name. Since the string starts, just do a string equals. Like that. So if it's that, then it's white pixel command Lemurian atlas ID white pixel. Okay, now start static bool strec str1 str2 bool result false if str1 lang equals str2 lang result is memek str1 pointer str2 pointer str1 length return result. Okay. Does this work? Maybe. Let's open render doc. Texture viewer, draw instance, inputs. Okay, well there is that white pixel. Okay, so seemingly that's fine. We packed it. We packed it in with that 1 pixel gap. Beautiful. Alright. Well, now we just need to refer to it. So let's see what that looks like. So if I just push rect, well actually, so I can refer to this pixel, right? But I can't. So I can refer to the, let's just 0 0. Okay, well, mirroring. Okay, so let's just refer to it this way. Okay, well, it is drawn. Seemingly. At 0 0. Now it's drawn behind. Okay, well, that's the first thing that's interesting. So why is it drawn behind? Let's figure that out. Output. What's going on here? So this is where when it cleared. Then we've got 2 fragments touching pixel. And this gives it a black color. And then something else comes in. And then something else comes in, and let's see, well, so it pulls out all the zeros. Input. Okay, actually, if we supply a different color, it will be easier to debug, I think. Okay, well, there's that yellow pixel. Why would it be drawn behind? If it's... Are they drawn in... Are they drawn in the... Oh, no, it's still behind. So it's not the order. Okay, well, like if we look here, that whole thing is kind of strange. Like, why is it being drawn like that? Okay, so this is presumably, if you look at input color, so this is the yellow pixel. It's drawn first. and this is the leg. It's drawn second. I mean, I guess that would explain it. Why is it drawn first? And why is it always drawn first? Like, okay, what if it's the only rectangle that's in there? Oh. Oh, now that's just what it looks like. Interesting. Okay, well, let's debug that. Yeah, it's probably our custom blending thing that it just doesn't work with one pixel textures very well. Yeah, like if you go here, and we look at these colors, so they're all transparent. So of course it would be like it is. It's just something about these one pixel textures. That's not quite working out. I mean, I'm sampling from the corners. And perhaps that's what's happening. The nearest pixel to the corner is actually the more transparent one. And it's only at the edges. But why is it only the edges that end up with sampling like actual yellow? It's strange, isn't it? Like right here, so we are sampling black, apparently. Okay, is this, I mean, this is yellow. I want to debug that. No, that's still all zeros. Yeah, there it is. Black. Am I debugging the right thing? Black? Oh, white rather. Oh, yeah, white. Yeah, no, white is what we want, yeah, because the actual texture is white. So bottom right is the only one that's like sampling that right pixel. Interesting. I mean, it might mean what are the UVs? Top left, bottom right UV. Yeah, no, this seems about right. So this is the span of one pixel, right? 0.87 to 0.95. And I just and does it make sense? Yeah, maybe there is an actual problem with how I'm sampling these things. So if we have a pixel grid that's small relative to how big the texture is, then let's go to the mesh viewer. back, well, any vertex will do. Okay, so the input, index 0, position 0, offset 0, texture in atlas top left is 21.1, dimension is 1.1, color is that, mirror x is 0, alright. So we go in, we go, okay, there's the vertex, minus 1, 1, so it's top left. So this vertex is that. So that's the top left, presumably edge. Oh yeah, but there's some weirdness going on with like whether it's the edge of the pixel or it's the center of the pixel that you're talking about. Oh yeah. Okay. So offset from center, if we just go back a little. Offset from center is 0.5, 0.5. So normally you would draw it at the center, but we want to align it, as in like in this example, we want to kind of align it to the left edge. So offset from center ends up being 0.5, 0.5. Well, bottom left, I guess. So it's being moved up to that, so that the bottom left, well, the whole rectangle is being aligned to that anyway. Of course, this is offset in pixels. So offset position is 0.5, 0.5. So that's the position of the center of the rectangle. 0.5, 0.5, that's in world space, which is correct. Let's see, can we draw some of this? Okay, I kind of want a line. Can you? Oh, there we go. So if this is a line, and just another one. Okay, this is the center, 0, 0. Then our rectangle, this yellow rectangle, right, is being moved. Its size is 1, and it's being moved to 0.5, 0.5, like right here. So far so good. Seems fine. Okay, so all these things, position and clip. So camera half span, well, camera is seeing 100 pixels each way. So position and clip being 0.005, that does make some sense. So its size is 1, yeah. Its size is 1 pixel in source pixels, but we're gonna scale it up to 100, essentially. Well, not 100, but we're gonna scale it up by some amount. Yeah, so if it's 0.5 in source pixels means 0.005 in these screen pixels. Dimension and clip. 0.01, yeah, so there we go. Dimension and clip space is 0.01. Because it's 1 pixel and it's seeing 100. So it's so that does make sense, yeah. Scale and clip is that 0.005, because the span of, if clip space is not 1, it's 2. Position in UV. I mean, that is what UV space is. Like if the texture is 10 pixels and you're at 5, then that's 0.5 in UV. Of course, there's pixel edges and then there's pixel centers. maybe that's what's messing with me here. Because text and atlas top left, I'm just referring to a pixel. Okay, so what's position on UV? On the X it's 0.91304. So if we go into the texture, let's look at the input. I would like to look at in there. Okay, so render.doc gives us UV coordinates down here. So let's see. So the edge of the pixel is actually 0.8696. And what I'm referring to is the center here, which is 0.193. So I'm saying, so presumably this is it. This is the coordinates I'm referring, 0.0714. Yeah. Okay, so position in UV. So this is the position in UV of the center. Which, I mean, so far this actually is making sense. So this position that I've worked out, this is the position of the center of the rectangle. And this is the position of the center of the rectangle in UV space. Okay, well, so far I think this is making sense. Okay, so this vertex is gonna be, I mean, index 0, right? Input index 0, so it's just gonna be that one, it's -1, times scale plus position. So this vertex ends up being 0 on the X. Which is, it's top left, so 0 on the X, yeah, that's correct. -1, 1, yeah, that is top left. UVs. Okay, so this part. Top left is 0, 0, and you end up doing just plus times scale. So this UV is 0.9134, 0.71, so 9134, so we established that's the center. Yeah. Okay, so I'm saying that the top left edge of the rectangle has that texture. Yeah, perhaps that's not actually what we want. So we want to move these UVs around, because the top left edge of the rect doesn't really have this texture. It has like this texture. Or does it? Does it? I mean, what happens with larger textures is the top left ends up being referring to the center of this pixel. And like the top right ends up referring to the center of this pixel instead of the edge of the pixel. It refers to the center of the pixel. Huh. Do we want to refer to the edge of the pixel or the center of the pixel? And pixels are much, much larger. I mean, everything else is what you expect it to be, really. It's... Yeah, this UV top left, right, that refers to the screen pixel. So basically the screen pixel is going to be sampling from like these 4 points or whatever. Dimension in pixel. Well, actually, let's see, what's dimension in pixel? 12.8 pixels. It's 12.8 pixels. So pixel half UV is 0.03. So going that much in UV space advances you by 1 pixel in screen space. Yeah. And so we go left, right, top, bottom, whatever. Well, actually, let's see. What are these UV top? Well, let's just look at the output. Output. Okay, so UV left is 0.873. Where are my coordinates? Ah, they're there. Can I... No, it just goes 0.7. Yeah, but like there's stuff in between. Can I see the stuff in between? Range 0, 1. Now it's colors. I mean, was this 0.87 and right is 0.95. I mean, that refers to different pixels in UV space. So that refers to this, and this refers to this, essentially. Except this is 952, and this is 956. Well, yeah, but when it samples textures from position 0, 0, presumably, like I'm doing nearest sampling, right? So position 0, 0 would just be like that. And anything that rounds to that would just sample from this pixel. Like I'm not doing blending in the sampler. So when I give it position 8, 7, whatever, the nearest pixel is this one. And when I give it position 9, 2, whatever, the nearest pixel is this one. So this one's just skipped. 9, 5 and 8, 7. Huh. Can we look at it again? Hold on. Dimension in pixels. Pixel half UV. 1 over dimension in pixels. Well, it's 12 pixels in size. Pixel half UV is 0.03. Well, 0.04 really. And if you add these together, you'll get something close to 0.08, which is that 0.7, presumably. Although not quite. Oh, that's interesting. So 0.039, that would be 0.78. Like these two together would be 0.78. But this is 0.771. 0.04. Does this make any sense? Maybe this computation doesn't actually make that much sense. Come to think of it. Okay, the dimension in pixels, so this part is fine. That is how big the thing is in pixel space. 12.8 pixels. Yes, because we are seeing 100 pixels on half of the screen. We're seeing 100 pixels. So 1/100th of that, and that's 1280. Half of the screen is 1280. So divide by 100, that's 12.8. Okay, so that part is fine. But perhaps this pixel half UV thing actually doesn't make sense, because what I'm trying to get at is like, well, if I go 1 pixel over, it's like, when do I start sampling from the next pixel in the texture, the next pixel? And if you just divide one by that gives you, well, if you advance 12 times, you'll go through the whole texel. If you advance 12 times by that amount, you'll go through the whole texel. At least that's what I'm trying to do. So 1 divided by 1280 and divided by 2, essentially. You get this number, 0.039. And, well, 0.03906 times 12.8. Yeah, so if you advance that much, 12.8 times, that gets you halfway through the whole texture atlas. Hold on, that does get you halfway through, but that gets you halfway through the whole texture, doesn't it? Oh yeah, so what I'm trying to get at is like, well, how many times do I need to advance? Because this is, we are only looking at a subset of the texture now. Like, this is the whole texture atlas. We're only looking at a subset of it. And I'm trying to say, so this texture, this 1 pixel texture is supposed to be applied to this 12 pixel, to 12 pixel grid on screen. And the point of that computation is actually to figure out it's like, okay, well, so in this corner we're gonna have essentially a screen. It's like, if it's aligned, if everything's aligned, then in this corner we're gonna have a pixel, and I just want the UVs for the corners of that pixel. And that's what I'm trying to do. Yeah. Okay, so it's not the text. I'm dividing by the wrong dimensions then. No, well, I mean, these dimensions are the right dimensions. But then this needs to be scaled further down to how big the actual texture is. because the actual texture doesn't go from 0 to 1. It goes from like, you know, point whatever. It's around this 0.9, 0.07. Yeah. So this needs to be scaled further down. Do we just divide by the texture dimension? Like, is that sufficient? Okay, let's see what that gives us. Gives us the same thing. But at least I'm doing that divide. So let's look at, I mean, I guess the top well, actually, let's look at the mesh first. Pixel half UV. Oh wait, no, it's not the texture dimensions, it's the proportion. It's the proportion of this texture in the atlas. So it's like divided by this ratio, right? The atlas dim, something like, what did I call it? Text dim. Atlas dim. And come to think of it, we already have that, right? Text and atlas dim divided by atlas dim. That's just scale in UV. Wait, it's not divided though, hold on. Yeah, I need to think about this. Alright, we have this thing that goes from 0 to 12.8, and we want it to basically go from 0 to the scale in UV thing. So like dim in pixels, if we just divided okay, so 1 over, okay, so what, just 1 over it would go in 12.8 steps, we would go through the whole thing. Okay, so this is like one pixel in the screen space. Is it? I mean, there are 12 pixels total. Yeah, okay. Okay, I think I know how to, so we have this number 0.5. Now 0.5, what I'm saying there is I want half a pixel. So half a pixel, that would be in screen space. So 0.5 comes from a range that goes from like 0 to 12.8. So if I just divide it by dim in pixels, now it goes from 0 to 1. Now it goes from 0 to 1. And now I need to multiply it by the new range, which is the scale in UV. Because if scale in UV, which is the proportion of the texture in the atlas, if scale in UV is like 0.001 or whatever, then that will be reduced appropriately, right? So I think this is it. And this is what the pixel half dim is. Okay, let's see what this gives us. Don't save this capture. Okay, so this looks promising. Okay, so we have some blending going on because it's 0.8, remember. It's 12.8 pixels. So this is like almost yellow, but it's blended. And it seems to be blended correctly. Okay. Okay, so what do the actual textures look like? They look, okay, so they still look, now we're moving this thing around. Okay, well, yeah, that does actually make some sense. Okay, let's push it last, so it should be drawn last. Yeah, so it's drawn on top. Alright. Again, there was a flash. At 47. Alright. Alright, so we can draw solid rectangles, but all of them are going to be 1 pixel. All of them are going to be 1 pixel, which is not really, you know, what you want for drawing grids and stuff. For drawing grids, we actually want to set our own dimensions. Which, well, I mean, we could just pass those in. Float to dim screen dimensions. And I guess these could just be, I mean, it's not really screen. It's world units, right? World. Yeah, this is world position. Screen position is not screen position, it's actually world position. And then the next thing would be world dimension. Well, position dimension, well, isn't that a rectangle? Should we just go back to that? Yeah, but with rectangles we have top left. And this is really different. This is position dimension offset. Like all of these. This is also world. Offset from what? I mean, we could just say it's offset from the top left. And that way all rectangles will work the same. And then these could be world position, world dimension, world offset. World rect. Yeah, so it's just that. It's world rect top left, world rect dimension, and world rect offset. Okay, world pos, world dim, and world offset. Because that's how I'm using it, right? And the world like our texture, like source pixels, those are the world units. So maybe I should just call it that, source pixel instead of world. srcpx. But then that's kind of weird, right? Source pixels, because like position 0, that's like the center of the screen. Position 1 is 1 unit away from that in source pixels. I guess that does make some sense. Position dimension offset. Yeah, okay. Offset off. Now we change rect instance again. Alright, so we've got a rect here. Well, actually we have a struct with a rect and an offset. Like that. And this is the world, position essentially. And then the rect is text and atlas, okay. Okay, so that then when we are pushing these rects in, okay, let's just do this yellow one. It's world rect top left, let's say it's top left, it's at 0, 0, so yeah, we kind of have to make that work. Offset is 2, okay, well, yeah. Of course, top left is... well, let's see how this works out. Is something the meta still? Yeah. Well, I mean, I'm not sure if I'm gonna keep it, so let's just do that. Okay, so it draws something somewhere. Let's see where. Okay, alright, so this pixel is 0.5.5. This is 0.5.5. This one's 0.5.5. Interesting, okay, interesting. So this is the exact, so it aligned to the bottom left. Essentially, yeah, right. It's essentially aligned to the bottom left. Should we align everything to top left? Or when it comes to world units, should we just say that it's bottom left? Well, I mean, if all of our texture rectangles at top left, yeah, probably just stick to top left. So if offset is 0, then we expect alignment to be top left. Which means okay, so offset from center is 0.5.5. 0.5.5, yeah. Okay, position dimension offset. And I'm essentially here, I'm essentially taking the position to be bottom left, so that needs to change. Well, offset from can I just flip it And that would be sufficient? I think it would be. So input offset, I'm only using it here. That's the one place I'm using it. So text and atlas dim. That's text and atlas dim is essentially flow to, like, it's essentially world dimension, right? It's the dimension of the object in world units, which are also source pixels. And why am I doing it this way? Well, on the x-axis, on the x, if the offset is 0, then you need to offset from center is negative. So it's, well, actually no, it's not really offset from center. It's more like offset for center. Because if the offset is 0, then the center should be moved to the right. But for y, since it's offset from the top, wherever you're moving the center, you just move it the other way. Okay, so what's this? Okay, this is 0.5. Okay, so that is the exact center now. So we said its offset is 0, we said its position is 0.5, is like 0, 0, which is halfway through the screen on either dimension, and that's where it's being drawn. Okay, well, that is what we want. Now, I'm also passing these dimensions. Okay. Float to... Well, actually... Okay, so I'm using these as the dimensions of the object, right? So now that we have two sets of dimensions, it's... Okay, so this text and atlas dim thing is used in these three places. Okay. The first time it's used, I'm using it as the dimensions of the object. Because offset, so offset is in the same units as the dimension of the object. So yeah, so this is actually, okay, let's pass in some dimensions. I mean, instead of passing dimensions, I guess we can pass in like multiply factor or something, but maybe not. Let's pass in some dimensions there. World rect top left is that. Yeah, world rect. Let's just set that. So it's got a top left, and it's got a dim which is gonna be like 10, 10 or something like this. So that's not being used anywhere, so that's not gonna change anything. Oh, actually, that's interesting. We don't just want to draw plain rectangles. We kinda also want to draw... Yeah, we don't just want to draw plain rectangles, that's the thing. Because if we draw plain rectangles, then that's like the minimum thickness. So if you draw a line, it's gonna be that thick. Which is not what you want. We want to draw stuff and specify the amount of screen pixels. Oh. Specify the amount of screen pixels. Well, right now these dimensions aren't used, so so like if I rename them, it still compiles, right? Yeah. Yeah, so right now we're just assuming that the dimension of what you're drawing, the dimensions of what you're drawing are the same as the dimensions of the object in world space. And I kind of want to specify that, well, sometimes we want to draw stuff that's in pixels, screen pixels, not source pixels. And we might want to specify the positions of those things in screen pixels as well. Is that a whole other thing, or can we just put that in here? Okay, well, first of all, yeah, let's... I mean, in principle, those are the only two, right? It's just some rectangles are specified in screen pixels, and some are specified in world pixels. But that's it. That's the only difference, and there's barely... I mean, I suppose that's not the only difference, because those rectangles that are specified in screen pixels, you presumably don't really want to do any kind of weird, like, blending on them. Because they're just gonna be plain... Well, they're not all gonna be plain, because we are gonna draw text. So, text will have textures in it. And some of the text will move around, so you kind of do want to blend it, so it doesn't like jerk around on screen. So yeah, we kind of do want blending. Although whether it's this kind of blending that we want is questionable. Maybe we just want standard bilinear. I mean, at that size it's gonna be standard bilinear anyway. Yeah, I think... Alright. I'm gonna go take a toilet break, think about this. Mute the microphone. Alright, exactly on time. Okay. Yeah, so this position and dimension. So to make solid, well, to make any kind of rectangle work whose position is specified using world, like what is the actual difference between world pixels and screen pixels in this case? World units. Well, like this whole camera thing is just not applicable. Camera, offset, yeah, most of this is just kind of not applicable to, well, not most of this, but like a lot of it. I mean, this still works for, this still works. Dimensions in clip space, to get scale in clip space. And honestly, most of this kind of just works for rectangles whose position is specified using screen pixels. Most of this kind of just works, except that this whole camera thing. Camera is obviously not applicable to them. So the way you go from world to clip there is first you offset. You need to use the offset. So first you offset this. Yeah, there we go. You take the input position, you offset it, then you move it to camera space, and then you divide to get the clip space position. And these operations would just be a little different for, like once you have the clip space position, you have the clip space position, and the clip space dimension. Okay, so up to here. So position and clip, and dimension and clip. So like this part is specific to our world rectangles, and everything else kind of is, well, camera half span. So camera is not relevant. So only this first part of the vertex shader is kind of specific to world rectangles. Everything else kind of isn't. So let's do some experimentation here. If false, then do all of this, and you can kind of see, yeah, the only things we need are float to dim in clip and float to pause in clip. If false, else, okay. So let's just assume that every rectangle we are passing in is in screen pixels. So position dimension can, well, I mean, we're not really passing in dimension. Well, actually we are now, yeah. Okay, so the position and dimension, let's say, can be interpreted as screen position and screen dimension. That means 0, 0, for example. Well, first we need, okay, alright. So position in clip would be input position, which is in screen pixels, divided by window dimension. So now it goes from 0 to 1. And then we just multiply that by 2. And we subtract 1 to transform into clip space. Except that the y is flipped. Okay, and And now dim in clip. I'm just gonna, well, actually we are, okay, you know what, dim and clip, well, I mean, it would be input dim divided by window dimensions. Yeah, I think that's it. Okay, let's just see what that draws. Okay, so that draws something in the top left. Okay, so that is kind of what you want. Launch application, launch. Okay, let's examine this texture. Alright. So it drew something in the top left there. It's not exactly 10 pixels in size. It's just like two pixels. Let's look at the mesh. Screen dimension is 10 pixels, so that at least is that checks out. So the first vertex. Oh wait, dimensions and clip, hold on. Dimensions and clip, so that it should actually be multiplied by 2 because the size of that is 2. Okay, so that's the first thing. That, okay, so now 1, 2, 3, 4, 5. I think that's 5 pixels. I wish I had a pixel coordinate here, but I don't. So so it drew that at the center, at the top, and at the center. And we presumably, like if we're gonna interpret it as the top left, then we kind of do need to offset. So there's no mirroring going on for these ones, so we just need to offset float to offset for center. It's gonna be half of the dimensions. So it's like we're gonna draw it at the center. So to draw it in the top left, x offset for x needs to be positive. And offset for y, because we're top down, also needs to be positive. So it's actually just input dim divided by 2. Float to offset position is input position plus offset for center. Okay, now position and clip is this offset position divided by window dimension times 2 minus 1, flip the y, and there's the dimensions. Okay, let's count pixels. One, 2, 3, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Yeah. So this is what you'd expect there to see there. So if we move it, so let's say 10 pixels to the right, it moves to the right. If we move it 20 pixels down, moves down. If we make it like tall, it's tall. All right. can presumably also do that, and it will do what I expect. C is beautiful. Well, I've mostly been looking at HLSL. C++ is more beautiful? Wow. What can you imagine? Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright. This is 10 pixels. No, it's 100.5, it's the other way. It's here. I made it 100.5 pixels. Hold on. What if I make it 1.5 pixels? Well, it's just a pixel. Inputs, no, not inputs. I want to look at the history. So nothing touches that. Even though the dimensions are 0.5. I mean, screen dimension, I call it source pixel dimension, it's not really source pixel dimension. Dimensions and glyph space. What if so like does it have to be like 2 pixels specifically to be like 1.8? Yeah, there's pixel centers though. Pixel centers at 0.5s. Okay. Okay, well now we have some blending going on. I mean, that is kind of what you'd expect. It's just, what are you referring to as the center, right? Here we have centers at 0.5s, so if you say that something is located at like 0 and its dimension is 1.5, is that gonna extend? Is that gonna extend to the next pixel? It's like this 0.5, this is 1.5, so if something's located here and its dimensions are 1.5, it doesn't actually reach this center necessarily, so it's not, this pixel is not included. Yeah, I think that's what's happening there. Whereas 1.8 would include this pixel center. And 2 would include this pixel center, but then you'd have to go all the way to 2.6 to include the next one. So like 2.4 will probably only have 2 pixels. Yeah, that's 2 pixels, but like 2.51, that should have 3 pixels. Yeah, there's the third one starting to appear. I mean, this is probably fine. It's just... yeah, this is just how it is. It's the center is on 0.5. If it doesn't include the center, then you don't see it. Fine, whatever. It's good enough. Okay, so what are we observing here? I think we're observing that in this path we only need, what do we need out of the input? We need the dimensions and the position. Whereas in the other path we need the position and whether it's mirroring and the offset. Whereas here we're never going to need the offset. And for glyphs, which we don't have right now, but we will eventually, for glyphs, it's essentially just this path. So, I mean, we could just keep these. For now, at least. And just say, well, if input pos is like source is world. And just switch between them like that for now. Maybe we'll come up with a better way of doing that eventually. But this will do. Pos is world. And since dimension and offsets are never really used together and never going to be used together, dim or offset. And position now, it's not source pixel position. And this is dim or offset. Like that. Float to dim is input, dim or offset. Input dim. Alright, we go in here and let's say float to input. Wait, hold on, but this is not dim, this is offset. Input dim is input dim or offset, like that. This is input dim. Okay. Of course, now I need to synchronize it. Oh my god. Yeah, I have zoom it running, so control 1 is not what I expect it to be. Although, I mean, I guess I don't really need it that much. Actually, I do. Do. Options. Okay, so zoom toggle. I mean, Control Shift 1, live zoom, Control Shift 4, draw, Control Shift 2, type, yeah. Break, Control Shift 3. Okay, so now Control 1, I presume I can just press, yeah. Okay, what was was it? I was trying to synchronize rect instance. Okay, so we've got what? Position dim or offset, so alright. Yeah, this is just gonna be like v2 position dim or offset. Yeah, it's just these two things. Position dim or offset, text and atlas top left and dim. Color. Mirror. And I guess we don't really need this path anymore because we're just gonna have an int pause is world. Oh boy, now we have this stuff to do, right? So the first one is pause. The second one is dim or offset. The next one is missing. Like then it's text pause, text dim, color, mirror X, and we have another one of these. Pause is world. Wait, RG. It's not RG. It's just R. Pause is world. Okay. Offset of rect instance pause. Then this is offset of rect instance dim or offset. Right. Then it's top left, whatever. Okay, now when we're moving these into the thing, okay, so this is gonna be position. This 1020 is position. This is dim or offset, is that. Texture, atlas, color. I also need to specify that pause is world. True. Well, actually false. This is false. Okay, so let's see. I didn't synchronize something. Source pixels pause. Okay. Oh wait, the shader isn't compiling. What's wrong with the shader again? Use of potentially uninitialized variable. Pause and clip. Oh. Okay, that is what it's supposed to be. All right. Yeah. Well, we have to specify that pause is world here is true. Okay. Well, okay, so we seem to be able to do both now. Yeah, all of that is the same for all of them. Okay. Yeah, I suppose if there is any art that doesn't, that's like higher resolution essentially than everything else, then we could just draw it one to one. We could just, yeah, we could just treat it as if it was a glyph or something and scale it that way. Yeah, so any art that's not one, yeah, so the only rect that we are missing is we have solid ones that are specified on screen. We have the ones that have the sprites that are specified using world position, where one unit corresponds to one source pixel. The only kind of glyph that we're missing is a glyph that has a texture. Well, it's a glyph that has a texture, so it's text, right? So a glyph that has a texture whose position is specified using the screen coordinates. We don't have that. We might also need a rect that has a texture, but it's not solid, and its source art is essentially higher resolution than every other source art. Yeah, but right now, well, I mean, I suppose that's the next step, is to add both of those. Well, the next step would be text. And see how that works out. Alright, so let's commit that. String equals white pixel let's just put them onto one line, whatever. Yeah, might as well free this. Okay, so alright, so we've got this going. That is all good. What's in the shader? A lot of changes. A lot of changes, but I think it's more correct now than it used to be. Yeah, alright. So this is like draw solid rects. Oh. Are we okay here? Yeah. Text. Well, we need the texture. Somehow we need the glyphs, and then we need to put them into this texture that we have, the one texture. Okay, so all of this is just reading sprite files. And I suppose we can just say, well, sprite files are good and all, but that's not the only thing that goes into the texture, it's also the glyphs. It's also the glyphs, which is like here. let's get ourselves a glyph texture. It's in here somewhere. Oh, there it is. Where do I want to put it? Maybe just here. Why not? Well, if you're gonna use it for very long. Because we're just gonna copy that over to the texture. Okay, how do I want to represent that in the enum of Atlas IDs? Now, do I even want to do that? Or do I just want to say, well, Atlas IDs are for sprites, and then all the textures are just separate to that. Maybe I just don't do that. All textures are just separate. Of course, if we're gonna pack them into the same, place, then, well, I mean, the special thing about them though is that they all have the same size. So we don't really need to scatter them around the atlas. We could actually just pack this into a texture of its own and then copy that and then pack that whole block in to the main one. Because these are all the same size, yeah, so we might as well do that. So texture, font texture. Alright, so font texture width is well, I guess we can so glyph count is how many glyphs do we have? 128 or something? And what's this? Well, we're gonna find out. Int x equals I think this is 256. Array count UI font. Compile. No. Uh, 256. Yeah, so it's 256 64-byte chunks. So 64-bit chunks. 64 bits, this is an actual bit map, so we've got each byte is 8 bits, and it corresponds to like pixels, And we've got 16 of those. So each pair of 2 of these is 1 glyph. Yeah. So 128 basically. We've got glyph count is 128, that's correct. Width is glyph count. Okay. Struct I32 glyph count. Count texture glyph width, that's the glyph count, glyph width, glyph height, texture font. Okay. Font equals that. And we know some things already. So glyph count is 128. And glyph width is 8. And glyph height is 16. So font texture is texture. Well, font texture width is font glyph width times font glyph count. Font texture height is font glyph height. And font texture pixels is arena, alloc, array, arena. Actually, what arena? Which arena are we using here? Scratch, right? Yeah, because we're not going to be using this long term. So allocate on the scratch me some U32s. And how many? Font texture width times font texture height. Okay, so that. Okay, so that is the font. Now I just need to fill in these pixels. Okay, I guess for each glyph. Glyph index 0, glyph index more font, glyph index plus. So for each glyph, U8 star bytes. Oh, I guess glyph bitmap. Glyph bitmap is UI font plus, well, I mean UI font, but we're gonna cast it as a U8 star. Plus, well, actually, do we have to? I mean, we know it's 2 bytes. UI font plus glyph index times 2. And just the whole thing is cast as a U8. I32 glyph bytes would be, well, it's 16. We just know that. So So there are 16 bytes per glyph. So for I32 glyph byte index 0, I32, glyph byte index is less than 16. I don't even need this. Glyph byte index plus plus U8 glyph byte is glyph bitmap glyph byte index. Okay, so we pull it out. So glyph byte index is essentially the row, and then for 32 glyph bit index is 0, bit index is less than 8, bit index plus plus. We've got a U8 mask, which is, I guess this could be a U8. So we've got bit indexes, so bit index, oh god, bit index left shift by 1, not by 1, one left shift by bit index. Okay, so that's the mask. Now if glyph byte and mask, that means that pixel is set. That pixel is set. So we kind of need to, like here, we need to do memset destination is font texture pixels value 0 size font texture width times font texture height times size of U3, so we know what's in there. It's size of like font texture pixels, right? Okay. Okay, so you need everything to 0 and then go through and just set some of the pixels. So if this, then font texture pixels text index is well, we just fill it, right? It's 0x ff 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 ff. It's that. Actually, we do have digit separators, don't we? Like with all that, is that allowed? Yeah, but like this is allowed as a digit separator, I think. Interestingly enough, like there. Okay, text index. Text index is something we kind of need to work out. Now, actually, yeah, hopefully that will work. Hopefully that'll do what I expect it to do. Well, okay, what's the texture index? Text index. Well, it's we need to go to the appropriate row. Row is just the glyph byte. Glyph byte index. That's the row times font text width. Okay, so that's the appropriate row. Now we need to work out the appropriate column, which is going to be glyph index times 8. So that's the start of the glyph plus bit index. So that's the offset. Okay, so that. Yeah, alright. Okay, we need to actually use this texture. We need to pack it, right? We need to pack it. Somehow. Well, I mean, there is our textures, right? It's this plus 1 for font. Then we allocate the array, we fill this in. And we could say it that either the first texture or like the last texture are the font texture. Although we don't really need to do that even. Yeah, we could just say that, well, Atlas ID just has an ID for the font. Perhaps. So that is the white pixel, that is the font. Now the font is just included. There is the font. So it will go through, it will fill the array with everything other than the font. Textures point. We can actually just do it here. Textures pointer Atlas ID font equals font texture. Just that. Textures. Okay. So that should be packed in with the rest of them. Let's look at what we get. Input. Alright. Man, the source art is like equivalent in size to glyphs. Okay. And we can pack all these in this way. Because we know they're all the same size. And there is this 1 pixel, except perhaps we should leave a 1 pixel gap between them. But that's not up to the packer, it's up to us to kind of just do that. Okay, let's just do that. So if we're gonna be leaving gaps, that means what exactly? That means we have glyph width times glyph count plus however many gaps we have. So if there are 2 glyphs, there's 1 gap, 3 glyphs, 2. Okay, so it's plus font glyph count minus 1 for gaps times gap width. 2 gap width gap width font gap width. There. Height is, yeah, we don't need anything for height. Okay, so now the texture is fatter. It's wider. So we go in, alright, and let's say texture index. What's texture index? Well, it's glyph byte index times texture width, that's the row, plus glyph index times 8, plus however many gaps we passed. I mean, this 8 is just font glyph width, right? Glyph index times 8, but it's actually how many gaps? So for glyph index 0 it's 0 gaps, for glyph index 1 it's 1 gap, so it's plus glyph index times font gap width. Plus bit index. Alright, well, it's not crashing. we've established that. Yeah, draw instance glyphs. Okay, so this, okay, there is that gap. There are so many symbols we can use. Look at that. We have arrows. Like all this useless ASCII range actually has some useful symbols here. Double exclamation. Okay, whatever that means. And we even have like a solid rectangle in here. And then just a bunch of text, followed by, whatever that is. And then this is our art. It's also here. Okay, so that's the text. We know where it is in the atlas. And since every glyph has the same dimensions, it's pretty easy to just offset into that. Okay. Okay, so I want to push one of those at least. So what's that gonna look like? Text in atlas. Okay. So it's, well, let's just do this for now, right? Font. Position is, let's move it down by 200. It's not world space. Dimensions. Well, yeah. I mean, dimensions, I guess, would be just whatever dimensions we have there. Yeah, and it's yellow. Okay, so we are cutting it off there at the beginning for some reason. So that's not good. Well, let's look at it. And also let's draw it in, I guess, in white. Okay, so what's going on there? Why is it cut off like that? That doesn't seem to be happening with the other textures we have. Just this one. Also, it's not drawn correctly. Like, it's supposed to have 4 pixels and then 2 pixels for the mouth. And it just doesn't. It draws it differently. Yeah, that's probably our blending. Yeah, the way, yeah, this custom blending thing is not quite working correctly for this. Like A is missing. Yeah, when it's one-to-one, it's really not, doing what it's supposed to be doing. Yeah, it doesn't quite collapse to bilinear. I mean, it'd be nice if it just did bilinear. Then we wouldn't have to worry about different shaders. Although maybe we should worry about different shaders. I mean, it is easier somewhat. Instead of having all these flags, just have different shaders. and turn on bilinear for the other one. And the scaled up art, draw it this way. Although maybe there is an actual error in the custom blend I have that's producing this outcome. And if that's the case, then that should be corrected. What's the position? 10 pixels, 200, dimensions, yeah. So like the history of this is mesh viewer. I mean, we kind of just want to look at that on its own. Mesh viewer. Well, those are the dimensions. Texture position is 1, 1, texture dimension is that. I mean, that does sound right. Yeah, that's the dimension. Just offset the center a little bit. Although it is being offset by half here, so that's probably why we're seeing what we're seeing. Because it's being drawn at like a half pixel coordinate, and that results in it just not sampling like it's supposed to be sampling or something. And maybe it would basically look like that with bilinearity. I mean, it probably wouldn't exactly. But yeah, it does end up being 580.5 pixels there, which is well, let's just out of curiosity, I suppose, let's see what happens if we just move it half a pixel to the right and then draw it. It seems a little blurred out. Yeah, definitely is a little blurred out. I mean, for what it's worth, it is kind of what you'd expect. And it's kind of even what you want. It's just if only drew this stuff correctly. Always something with these. Alright. Well, that is the offset position, 580.5. That's the center. Alright, scale, whatever. There's the vertices, so the first vertex is there. Almost at the left edge, that's the minus 0.99. scale and glyph, I mean, yes. Otherwise, this actually does seem like what it's supposed to be. Well, let's see here. So there's supposed to be like something here, right? It's 4 pixels and then 2 pixels. Is there a 1 pixel gap? What does this glyph look like? Yeah, there's a 1 pixel gap. It's like it doesn't quite reach the pixel center or something. That's why it's not drawing it. And like, it's not there for some reason. So if we look at what we've sampled, this is bottom, this is top. So we only sampled 1 white pixel on the bottom left. And blend factor, by the way, ends up being 0, 0. So it's just the top left. Yeah, well, that's the rounding thing, right? It's like we have these 4 corners, and we're sampling the nearest pixel to those 4 corners. And only the bottom left is the white one. Everything else ends up being not that. I mean, I guess we could look at the UVs. Top, bottom, left, right. UV left is 0.005. Yeah, I mean, these are like extremely close, like 5. Well, top left certainly ends up being 0. And bottom right is 0, so that's just this one. Like if you look at the 4 corners there, well, you can kind of see how bottom left would be white. White, or like top left, I guess, ends up sampling like from the top here, and this ends up sampling from here, and this ends up sampling from here. So none of them actually sample from the center. Yeah. Yeah, this kind of sampling only really works when you scale up the textures. Like when the source pixel is much bigger, like at least 2x bigger than screen pixel, that works. If it isn't, then yeah, this is really not gonna work all that well. If it's 1-to-1, then we should just use bilinear. Like if we're gonna blend it all, it's gonna just be bilinear. So we still want to pack them into the same texture. But we want a different vertex pixel shader pair that just does bilinear. And we might as well use that for solid rectangles as well. Like if we're gonna have a separate pair, might as well use it for everything. for everything that makes sense for. So maybe just do that. Well, new file or no. I guess this is something like no. Pixels. Screen. Just call it screen HLSL, I guess. Okay, and okay, so what do we need? So we need position, dimension. We do need the texture. We do need the texture dimension as well, yes. We do need the color, we don't need either of these. Okay. In here we're just going to be passing the UV and the color. C buffer, well, I mean we could just use the same C buffer, like there's no reason to change that. Sampler is going to be different. Texture is going to, well, it's going to be the same texture. So it's the second part that will execute here. Float 2. So remove that. Move this. Input dim becomes input dot dim. Everything else kind of the same, except that UV is just this UV, like that. Without mirroring. Which is why we can just do this. Pixel shader doesn't need to do anything. It's just input color plus, well, it needs to sample the texture, right? So it needs to do one of those. Text color, sure. And yeah, this is just input UV. Okay, that's it. So that's it for the screen shader, I think. That's sufficient. We don't need to change texture packing, actually. We do need to change these rectangles. So some rectangles will go to one of the arrays, and some of the rectangles will go to the other one. I mean, I guess every sprite will be drawn first, so yeah, well, we'll figure it out. Yeah, alright, so now we need to compile these shaders and like set them up. Just always always a good experience. Alright, so it's basically that again. So I probably want to pull that out. And it should be after, well, after some of this. Oh, there we go. Let's look here. Static void d3d11 create vs ps vertex shader, pixel shader, whatever. And it's essentially just that. Temp memory block arena. Okay, so what do we need? Well, we do need this memory arena, so that's passed in. The description is gonna be different. So yeah, so this is gonna be input element desk, i32 desk count. So let's just remove that. Alright, so this is interesting. So we are reading a file whereas this is basically the name of the file. File name. Okay, so this should be format arena, and then instead of this we just pass in file name. Well, it's that. Okay, so shader vs, shader ps. Okay, so we do need some of this stuff as well. V shader, P shader, and layout. Okay. Well, that's basically type def struct d3d11 vs ps. Let's just call it that. I don't really know. And in here we have whatever that is. I think it's d3d11 vertex shader. No. Alright, well, let's find out. Yeah. Okay, so V shape, yeah, so it's these things. Okay, V shader, P shader, and then also layout. Well, yeah, let's put layout first, and or not. Yeah, it doesn't really matter. And d3d11 vs sprites, and then we have another one for screen rects. Sprite rects and screen rects. And well, yeah, so sprite, okay, there we go. All right. I guess what that means is that we have kind of two different types of rects. It's like type def struct d3 d11 sprite rect. Yeah, so we have this rect instance thing right up here. Yeah. Well, no, this needs to be down here. It's just... Alright, so I'm just gonna rename this to sprite rects and... Alright, so sprite rects they have position and offset. And text and atlas, rectangle, that's text and atlas. Color, maybe color. So do we need color? And the other type of rect is just screen rects. Well, I suppose it's sprite rect. Screen rect. Okay, screen rect has position dimension. Text and atlas color, yes. And it doesn't have a mirror. Okay, so that's screen rect, and then there's sprite rect. Okay, what's this? Okay, well, this has, alright, there's a lot of things going on. So all of this, oh, it's gonna be different, alright. Okay, so struct rects. So we're gonna have sprite and screen. That's sprite and screen. Both of them are gonna have a buffer. This is gonna be sprite rect, and this is gonna be screen rect. Like that. Rect, sprite. Okay, so that. Alright. So we got sprite rects, we got screen rects. Each of them gets a buffer, each of them gets a storage that we're going to be copying around, and they're all under rects in d3d11. Okay, this seems about right. Okay, so what does this function return then? It's supposed to be returning one of these. Oh, yeah, about that. So each of these, not only does it have a buffer, but it also has this layout, vertex shader, and pixel shader. So it's like D3, D11, VS, PS, VS, PS. It's like that. So we don't actually have that. Blend state. Blend state is also going to be different between them. Okay, vertex shader, pixel shader layout, those things are gonna be different. Blend is gonna be different. Rasterizer is not gonna be different. Actually, blend is not gonna be different. Hold on. It's the same texture, it's the same C buffer. Assuming we even... Do we need... Oh, we do. Yeah, we do. Well, I mean, Atlas Dim... No, yeah, we do. This thing we don't need, right? Yeah. So it's the same texture, same swap chain, same device, same context, same C buffer, same texture, not the same sampler. Different samplers. But it is the same blend. There. Same rasterizer and same RTView. Okay, well, I think that this is it. Okay, so this returns just one part of that, which is this VSPS thing. Result. Okay, so we need the device. ID3D11 device. This array count desk turns into desk count. Layout, P shader, V shader. Okay, so all of these things are now a result. Return a result. Like that. Okay, so input element desk star. Yeah, of course we are. I forgot about the fact that we are in temp memory here. Okay. Okay, alright. So rects storage capacity. Well, this will just have to be duplicated. So this is gonna be sprite. Sprite. What is this again? What did they call it? It's sprite storage capacity. Sprites. Oh no, it's rects.sprites.storage capacity. Rects sprite storage capacity. Rects sprite storage pointer, rects sprite storage capacity. Alright, arena like array, rect instance is gonna be sprite rect that. And then we do this for, so sprite becomes screen. Okay, now this is the shader. All right, here we go. Like, we don't really need temp memory block anymore because we're looking at the allocating. We just need the description, and then we need to say, well, so this initializes the capacity, the storage of the sprites. Where is our, yeah, so the storage is initialized. Now we need to initialize this VSPS thing. Oh, in buffer, actually. So this part we handled. Now this VSPS thing. So there's the description. Then we call this function, right? We give it D3D11 device. We give it an arena. We give it the description. We give it array count description, and we give it the file name, which is gonna be clone.hlsl. That. Yeah. So this is for D3D11, rects, sprite, VSPS. I guess I can call it sprite. Or clone sprite.hlsl. Yeah, and sprite requires these things. So it requires position. We've got that. Okay, all of these would be sprite instance. Sprite rect. Position, dimension. Okay, so sprite, well, this is just dimension. Text and atlas top left, text and atlas dim, color, mirror, maybe. All of this remains, all of this remains, all of this remains, all of this remains. So pose is world. Okay, so that's the only path that's happening here. Float 2. Okay, input offset is just input offset. So that's not the dimension. This is offset. everything else is the same as it was. Offset off, offset. Okay, do we have like right, rect, pause, offset, text and atlas, top left dim, color. Okay, so this is offset here, text color, mirror X, that's not in there anymore. So VSPS is just that. We don't need to do this. And now let's just do that again, but for screen. So we've got pause, we've got dim. Okay, so all of this changes to screen. So pause, dim, text pause, text dim, color, and there is no mirror anything. Right. Rects, sprite. It's a screen. Okay. Yeah. Okay, what's next? So we go in. Sampler. Oh wait, it is blend. No, it isn't. It isn't blend. No, it isn't blend. No, what? No, that is, yeah. Alright. So sampler, rects, sprite, sampler. There we go. So this sampler is for the sprites, and this other sampler we're gonna write, which is gonna be for the screen, is going to use something other than this. Okay. Min, mag, point, mip, linear. Yeah, you know what? Good, sounds good to me. Yeah, I think this is the one we want. Clamp, clamp, clamp. Okay, so something like this, right? Oh, yeah. What's next? Okay, what? Yeah. Where are we pushing these rects? Alright, well, this rect is clearly supposed to be screen rect. So screen rect would be screen rect, position, dimension, text and atlas, color. That's not something we're doing anymore. So screen. Wait, it's rects.screen. It's that. Yeah. Okay, so that's rects.screen. Now this stuff I'm just gonna turn off. Yeah, I've got, what is this? Okay, so we are mapping the rects buffer. Rects dot sprite dot buff discard, then memcopy rects dot sprite dot storage dot pointer rects dot sprite dot storage dot lang rects dot sprite dot storage dot pointer. Okay, Okay, well, this I guess I'll just have to copy and paste. And rects.sprite become rects.screen. That's C buffer. Set input layout. Okay, well. Alright, well. Clear view, that's the same for everything. Now we've got differences going on. So we've got this could be pulled out, I'm guessing. I mean, up to where are we? Well, it's up to draw instanced, yeah, so it's all of this. Okay, well, blend is actually the same. Samplers are different. Shader resources. I mean, blend is the same, but like, might as well. Alright, so all of this. Oh my god. No. Control C. Control C. Alright, so in here, we're just gonna have another one of these static void 3D11 draw rects. And then, well, we'll just see what we need. We need context. We need layout. Well, we need VSPS, right? A3D11 VS SPS VSPS. So layout becomes VSPS layout, and that's the rect size. No, just call it whatever uint. So this is the vertex buffer. Oh my god, what's that thing? What's the type of that thing? Why? Oh, it's always ID3D11 buffer. VBuff. It's this thing. And then, oh yeah, then I've got C buffer. C buff. D buffer, C buffer. V shader would just be VSPS. Viewport. I mean, might as well pass it in. viewport. A rasterizer. What is it? ID3D11 rasterizer state, rasterizer sampler. Sampler state sampler. Texture view. What even is that? Shade resource view. Texture view. That's a lot of things we need, huh? P shader, VSPS, P shader, blend state. I mean, it's almost that whole thing. RT view. Rect count. It's like I64 or whatever. Rect count. Yeah, that is a lot of stuff we need. So it's basically this whole thing, but like this is this is different. And that is different. Well, let's keep it like this for now. Can't really see any good way to express that other than just this. Like, it's clear screen and then D3D11 draw rects. D3D11 context, D3D11 VSPS would be rects. Sprite, VSPS, rect size would be size of rect instance. V buffer is D3D11, rects, sprite, buffer, C buffer is D3D11, C buffer. Buffer, viewport, D3D11, rasterizer, D3D11, rects, sprite, sampler, 11, texture view, blend state, RT view, and then rects, sprite, length, storage, length. So it's that. Okay, so yeah, I should really group them, but at some point. Okay, so rect sprite become rect screen, and this is screen rect. So that's screen rect, and this is sprite rect. Static void d3d11 destroy VSVS d3d11 VSVS. Yeah, so this would be these things. d3d11 destroy VSVS. D3d11 rects sprite VSVS and rects screen. So that, more or less, is what we want. Okay, so this compiles. The shaders don't compile, apparently. Failed to open file. Compilation failed, yeah. Okay, so ROR clone HLSL, so this part. Now this is ROR clone sprite. And this is ROR clone screen. So sprite and screen. Screen, right? Position, dimension, texture, position, color. Yeah, so that is screen. So something like this is what we want. So, okay, so compilation succeeded, sprite succeeded, screen apparently did not succeed. Oh my god, did they have dashes as well there? It's not picking tasks. Yeah, so this thing, well, it's digit, right? But it could also be digit optionally followed by dash and optionally followed by some more digits. It's alright. Output VS is not completely initialized, so let's see. Color, we're not passing in color, is that output color is input color. Alright. UV is this UV. Float 2, of course. Okay, so all of those compile. Now let's see. Okay, we are displaying something. We can't release this. Release should not be called an object with 0 reference count. And that wasn't the problem before. That apparently wasn't the problem before. Oh wait, we did. We are setting the C buffer twice, but it's the same buffer. Maybe that's... Shocking news about the dev who made Bioshock. What are these shocking news? rs set state, rs set shader. Where is this C buffer? Well, isn't there more than one dev that made Bioshock? It wasn't a solo dev endeavor. Let's just call it cbuff. Yeah, there it is. What if I just set it here? Like clear around the target view and then just do that. Except well, context is just D3G11. D3G11, C buffer. So just set it once. So whatever the shaders are. Although, I mean, it is kind of weird. It's kind of weird that it gets upset about that. Okay, well that does work. So how was this not a problem before? Device child reference counter underflow. What is it even talking about? What? Okay, what if we just don't do this? Is it gonna work then? No? I'm not even sure if it's the C buffer or it's something else. Let's find out. No, it's not. It's not the C buffer. Never mind. Okay, you know what? Let's just move this. Roll this back. Okay. Close. Okay, so one of these has like 0 reference count or something. And somehow that's a problem. Just don't release it if it's got like or like force release. Like why is it getting? Wait, hold. Is this a warning or what? It's unclear if it's a warning or what. Parameters. Man, look at this useful like debug log over here. It's just so good. And there's 3 of them for some reason. Okay, so one of these is throwing, and I guess it's like this. What if I do that? It's still not clear which of these is. Okay, you know what? Let's just do them one by one. That one's fine. That one's also fine. That one's also fine. That one's also fine. Oh. Oh, wait. God damn it. Okay, so something is still alive by the looks of it. What is still alive is the question. D3D11. Okay, well, when releasing the device, the context, the swap chain, rects buffer, sprite buffer, sprite buffer, screen buffer, sampler. Okay, there's definitely gotta be a better way to do that. Okay, nothing's alive. We killed all of it. Alright. And what's the result? The result is that we are drawing these things correctly, I'm pretty sure now. Now that we have bilinear enabled. Let's just zoom into that. I mean, I guess I can just, hold on. I guess I can just use zoom it. To zoom in. If that's all I need. Alright, now, let's see if we actually do have bilinear, though. Which I'm gonna see like that. So, storage, so it's rects, screen, storage pointer, position, x plus equals delta. Well, I mean, it could be just something very... I mean, this is pixel position, so let's see. Yes, oh my god. This is too slow. Okay, now it's moving. Okay, I'm not seeing any like just snapping to the next position. Where is my filtering? Which I did set, right? Maybe I didn't set it properly. Yeah, so that's the sampler. Is the sampler being passed in to draw rects? Screen sampler, yes. It's being passed in, presumably it's being set. Filter min mag point. Oh wait. Filter min mag linear mip point. That's what it is. All right. Zoom into that. Yeah. So now we can see it blending. Alright, blending's done. I mean, rects are done. Let's see if we can still draw the other rects. Rects sprite storage. Sprite rect position, texture, nutless, color. That's not necessary anymore. Alright, okay, so we can still draw that. What is going on with the edges there? Why does it just disappear? Like, what? Like, instead of smoothly like blending in, it just kind of disappears. Boom. What? Why? Why would it do that? Like, all of these smoothly disappear, but not that one. Yeah, like this one. Yeah, it just smoothly blends out. That one, it's like smooth, but then it just isn't. Even though there is a one texture, a one pixel pad, so that it could just smoothly disappear. Is there the same problem on the other end? Yeah, kind of. It just appears like suddenly. Boom. Yeah. Should I include the transparent pixel into the... Yeah, that's what it looks like. like I'm not including the transparent pixels, so it's not sampling from them or something. But if I just include the transparent one, then it will? Maybe. Well, I mean, alright. So that would be in here, where I've packed them. Textures pointer, textures trimmed, Atlas locations, yeah. Like, I could just not do this, right? And then width would actually be +1. Like, it's the packed rectangle, and the texture would actually include that empty one. Yeah, it does solve that problem. Of course, now everything has that. Yeah, now we see the next. Wait. So, should there be a 2-pixel gap to avoid this? I mean, that's definitely not good. But like, yeah, I guess the transparent border should just be included into the texture coordinates. I mean, which means this needs to be padded out by 2 pixels. One of them is already included, and the other one we include ourselves. Well, I mean, if there needs to be a 2-pixel pad for everything, then the easiest way to achieve that is to actually just give everything a 2-pixel pad. So let's not pad out the atlas, and instead the bracts that we pack are just going to have 2 pixels on each side. Yeah, this is just that. Yeah, well, that is correct. I mean, that's what it's supposed to do. I mean, it's not great exactly, this. Like, you can kind of see it changing brightness. But, you know, if we're gonna draw text at arbitrary locations and move it around, then, well, it's not really gonna get any better than this. let's verify and run the dog that we actually are. That draw instance, so the input here, well, it's the same texture. That still seems like, looks like a 1 pixel gap to me. Ah, well, that's a 2 pixel gap. That's 1, yeah, but that's fine. Like between textures we should have 2 pixels. And we do. And here, right. Yeah, I mean, that's fine. And there is that single pixel that we also have. Yeah, okay, well, let's close all of that. Let's throw another one of these. Yeah, this. Okay, what are we pushing in with? Sprite, rect, position. 1 pixel, yeah, whatever, that's fine. Let's do Lemurian for this one. Color, possibly don't need that. Well, actually no, let's do Lemurian here, right? But let's do a mirrored commando. And a Lemurian that's not mirrored. And we're gonna move this to the right. And I guess down. And also this line. Just, okay, right, screen, storage, rect instance, dim, offset, so that's not there anymore. I guess that's the white pixel one. Okay, we're pushing in this thing. It's not dim or offset anymore, it's just dim. Okay, so, oh my god. Oh, now it's that line that's moving, and that's what it looks like when a line moves. It flashes. Well, I mean, it either flashes or it teleports. Like, there's no other way to really move it. I mean, I guess you can, like, reduce its brightness or something if it's... and make it move smoothly, maybe. Maybe. Okay, so this isn't happening anymore. Now, let's turn this back on. So this is rects sprite. I mean, I guess I can just say sprite rect sprite is and just do this. Alright. Well, this pretty much shows everything we can draw. Where's that line? Alright, so dimensions, let's make it 4 pixel line, something like that. Interesting. So it's kind of weird. Oh, yeah, because we have that transparent border, right? And for the line, oh my god, and for the line specifically, that's actually kind of not good. Yeah. Yeah, because like once you get to the end, you're starting to blend with the transparent pixels there. It's almost like you kind of want that custom blend specifically here. I see. So it's like we kind of want a 2 pixel gap, but we also kind of don't want a 2 pixel gap. We kind of want to include the transparent border, but only sometimes. Okay. All of that needs to be sorted out. Okay, that we're compiling with no errors, yes. Okay, so the things I need to sort out is how big the gap should be between the textures, and whether the transparent border should actually be included or not, or maybe it should be included in general, but well, the 1 pixel border was actually working just fine. The only context where it doesn't work so well is this is moving text around. Because if your glyph, like if the rect that you're drawing has the glyph on it and it doesn't have that border, then it's not gonna be, like you're only blending what's inside, you're not blending what's sort of on the outside. Well, I mean, you are blending what's on the outside, but only when it happens to move into the pixel center. So you end up with, alright, so maybe I should go back a little bit here and just say that, you know, we're gonna pad these rects out by 1. We're gonna pad the atlas width and height by 1, and we are not going to include the transparent border into the textures. So this is exactly how it used to be. Now we have a 1 pixel gap and the border is not included. So that's what that looks like. So that's still being blended. Interesting. But like only on the edges. So we don't actually want the blend. Yeah, we might not want a bilinear blend there at all. Actually, let's see what happens there with the nearest blend. We just replace linear with filter min mag mip point. Yeah, now it draws it exactly. But once you start moving it around, it will snap to, it will not move around smoothly. But then again, if we do move it around smoothly, it will change brightness. Okay, I guess for now we can just leave it like this. Okay, and I'll put it to do here. What kind of blend should we have here? It might just be this nearest, this might be fine. Or maybe it won't be. Oh, actually, can we like zoom in and look at what's happening here? I mean, I suppose I should reduce the speed of movement. Even less than that. Maybe too slow. Nah, that's fine. Okay, so this is the kind of blend that I chose to do here. And it does seem to be working, for what it's worth. Well, again, the edges are disappearing. Internally it's blending fine. The edges are disappearing. What just happened there? Hold on. Let's not mirror it. Yeah, so like here, you can see how the edge is disappearing. What? There's also this weird, like, what is even happening there? It's like it's not there and then it's there. Is that rounding or something? Like, ooh, that's really bad. Wow. I mean, it might be related to that same problem of disappearing. Maybe. I mean, yeah, it might be the same problem. Unless it isn't. And in terms of the actual blending logic, like if you look at it what's happening inside the texture, that's all fine. It's just the edges that are being a problem. Or like here, like whoa. Yeah, this flickering right here, that should not be happening. And that's even happening inside the texture, actually. So there is so there is at least two problems. And that might be due to rounding. Oh man, if that's due to rounding, then like how do you even fix that? Yeah, it definitely is happening inside the texture. Yeah, right here. Like, what is that? Why? And why here specifically? Like, it's not happening on the other side of the leg, it's only happening on this left side of the leg. Okay, well, that's two problems to fix at some point. So one of them is to decide what kind of blend should be used for the solid rectangles. Another one is where do I even put it? I have here. Fix jittering edges of textures, and a separate problem here, custom blend seems to, how do I even describe it? Okay, seems to result in some edges, including internal, to flicker in and out sometimes, and that needs to be fixed somehow. Well, another one. Okay, so this probably, I mean, compress these two, maybe. Compress better somehow. I mean, the problem is that they have this pointer here, but I mean, you kind of want to retain the type. So, and there's probably a way without resorting to like weird macros to do that. Although, I mean, maybe there isn't. Okay, so this part is fine. Yeah, this part is fine. This part is fine, actually. The font is fine. font being packed in is working correctly. Decide on the blend, which is related to these things. But other than that, this is fine. Okay, so these things should probably be compressed. And these better function interface. It would be nice, although that's related to like bundling this data somehow in a better way. Okay. So if I exit out of this, no errors. Alright. Yeah, that's fine. That's also fine. It's also fine. Font screen rect. Sprite rect. That's some new code there. Alright, okay, that seems fine. And that one's deleted, yeah. Okay, let's just make sure I didn't mess anything up. No, it's all working. Alright, well, let's add font, add glyph, and solid. Well, actually, solid was already committed. Add glyph rendering. Like that. Yeah, every time you do a git commit, the language server for HLSL just completely crashes immediately. Like whatever it's doing there, it's not working. I mean, it is working otherwise. Alright, well, that's all for today. Thanks everyone.